Welcome to this explainer. Today, we're diving straight into the pure, unfiltered mathematical mechanics behind the Zambian 2026 general election results. There's always a ton of political noise surrounding elections, right? But we're going to block all that out and look strictly at the numbers. We'll analyze the reported 2026 results from last week using a framework that asks one very specific question. Just how mathematically resilient is the reported outcome? And where exactly should we look to verify it? Let's get into it.
Okay, so our entire analysis today is guided by a core doctrine from the CopperCloud research framework. Think of this as our scientific observability instrument. We're intentionally stripping away all the political rhetoric. Why? Because, and this is key, a statistical anomaly isn't a smoking gun for manipulation. Not at all. Instead, it's a brilliant, purely mathematical way to identify exactly where we need additional documentary verification. It takes the emotion completely out of the audit process and replaces it with cold, hard data. To test the arithmetic robustness of Hakainde Hichilema's reported 60.49% against Brian Mundabile's 37.87%, we're passing the data through a 6-step analytical funnel. We've got 1, result observability, 2, record completeness, 3, historical fit and turnout, 4, the composition effect, 5, outcome sensitivity, and finally 6, local margins.
Part 1. Result observability and framework, establishing the baseline. To really properly analyze the 2026 Zambian election, we first need to agree on the strict rules of our data framework. So, the crucial point here is understanding the fundamental difference between an election count and an opinion poll. In everyday conversation, you'll hear people toss around the phrase margin of error when talking about election disputes. But scientifically speaking, that's a massive misuse of the term. See, an opinion poll is a survey of a sample. It's estimating reality. So yeah, it has a margin of error. But an election count? That's a statistical census. It counts actual physical ballots. No margin of error applies to a census. A discrepancy in a census is an accounting error, plain and simple, not a statistical variance, and we absolutely must treat it as such. Part 2. Evaluating election record completeness, mapping the data. This basically means we need to evaluate exactly what data we currently have in our hands and what is still missing while we wait for the official ECZ release. But before we look at the numbers, we actually have to look at the map. In 2025, a Constitutional Amendment Act expanded the Zambian electoral map from 156 constituencies up to 226 constituencies. And this expansion happened just months before the 2026 election. This is massively important, guys, because it means we literally cannot do a simple one-to-one comparison with 2021 totals. All the 2021 data we're using today is strictly, and I mean strictly, for comparative baseline context. Now, what's really fascinating about this specific data breakdown is how it completely dispels the myth of missing votes. Based on the retained media record from Mwebantu, we have individually attributed data for 222 out of the 226 constituencies. That accounts for about 4.76 million votes. Now, there are 4 constituencies, which represent 58,551 votes that are currently recorded only in the aggregate. Those votes aren't missing. There's simply a geographical attribution gap in the early media reporting. It's a gap that will instantly be filled the moment the ECZ publishes its final granular data. We also have to be super responsible with how we handle differing media records. You might see one data set from Mwebantu covering 226 seats, and then another from Zambia Decides covering 192 seats. Let me be clear. These data sets do not invalidate one another. They simply measure different reporting scopes based on exactly when they aggregated the live announcements. Understanding this ensures we evaluate the data responsibly, without jumping to false conclusions about discrepancies. Part 3. Historical fit and turnout, pre-declared expectations. Let's look at how we responsibly test the incoming 2026 data against strictly sealed historical models. The absolute strongest protection we have against hindsight bias is building a model before an election even happens. Using 2021 historical data, this framework established baseline turnout expectations and essentially sealed them in a vault before the 2026 results were known. It calculated a median 95% expectation band of plus or minus 7.08 percentage points. So what does this mean? When the ECZ publishes their final figures, any constituency that falls outside that band won't automatically be accused of wrongdoing. Instead, it gets mathematically flagged for standard documentary review. It's just a highly targeted, perfectly impartial way to audit. Part 4, the cohort-composition effect, fair geographical comparisons. Let's move along and see how this builds into our next concept,
showing exactly how isolated numbers can be incredibly misleading without the proper geographical context. Take a really close look at these rejected ballot rates. If you compare a partial 2026 reported cohort of 47 seats, which had a 3.13% rejected ballot rate, to the 2021 national average of 2.55%, well, it looks unusually high. Someone looking at that might easily shout anomaly. But wait a second. If we compare that 2026 cohort to the exact same 47 seats from 2021, the rate back then was 3.14%. The anomaly practically vanishes into thin air. This is the composition effect in action. It perfectly proves why you absolutely must compare like-for-like geography to understand what is truly unusual.
Part 5. Mathematical Outcomes Sensitivity, the scale of the lead. We now arrive at the absolute mathematical core of this explainer. When election results are contested, the debate often focuses on whether the count is accurate. But mathematically, we must also ask a second, equally important question. How sensitive is this outcome to discrepancies?
Let's look at the numbers objectively. The reported results from last week establish Hakainde Hichilema of the UPND winning with 2,965,326 votes over Brian Mundabil of the Tonsi Alliance with 1,856,222 votes. That establishes a staggering two-candidate lead of exactly 1,109,109 votes. To overturn this specific result through direct vote switching, it would require exactly 554,555 votes to be directly flipped from Hichilema to Mundabili. Think about how the math works here. Because every switched vote reduces the leader by 1 and adds to the challenger by 1, the margin closes by 2. So it would take well over 500,000 direct switches, or roughly 11.5% of the total two-candidate vote, just to erase that lead. Now, this doesn't validate the tally as flawless, but it firmly and undeniably establishes the massive mathematical scale any alternative outcome theory has to account for.
We can actually apply this exact same sensitivity logic to rejected ballots. Because we don't have the final 2026 national rejected total just yet, we can model extreme scenarios based on historical rates. Even under the absolute highest modeled scenario we've calculated, which implies roughly 194,000 rejected ballots nationwide, that total is still only 35% of the 554,555 switched votes required to reverse the election. It is mathematically incapable of altering the national outcome on its own. Part 6. Pinpointing crucial local margins. By establishing these national sensitivity bounds, our scientific instrument now tells us exactly where to look next. And this brilliantly illustrates our broader point. Statistical focus absolutely must shift to localized audits where every single ballot carries real weight. For example, back in 2021, there were 9 out of 155 parliamentary seats, like the historical contest in Chadiza, where the number of rejected ballots actually exceeded the candidate's winning margin. In those specific, highly contested local races, an accounting error genuinely could change the outcome. Because local margins matter so much, a strict reconciliation protocol is set to trigger the exact moment official data is released. As we've outlined in these 8 steps, this involves performing exact record matching, conducting full ballot accounting audits, and scoring all 226 constituencies against our sealed expectation bands. This allows us to mathematically target where local audits are truly needed, rather than relying on emotion or guesswork. Ultimately, this entire framework elevates the conversation from vague allegations to testable, concrete mathematical propositions. So I'll leave you with this to think about. By removing the political rhetoric and relying purely on arithmetic robustness, how does mathematically targeting local margins fundamentally change how we observe and audit African elections moving forward? Thanks so much for exploring this data with me today. Keep asking the hard questions and always let the numbers guide the answers.